So this next slide, or a couple of slides, are more or less straightforward, but I noticed I ran into people who didn't know that. So I figured if you take this class, at least know these few things right here. And so simple graphs. Line graph that looks like that. Typically, they work because what the line is the important feature, the fact that the points are linked with a line. So that kind of suggests, look at this line between this point here and this one. That suggests that there is something in between, at least. Well, that's the best solution. So if the data, the x-axis, and really the y-axis as well, should be more or less real numbers. So numbers that have intervals, and between every two numbers, there's something in between. It might also work relatively well for things that are ordered, Sunday, Monday, Tuesday, Wednesday, because you still see a pattern. And it's probably going to be completely, the worst possible usage would be for nominal data, because between cat and dog, there's nothing in between, yet there's a line showing a trend. The other thing is I can flip the cat and the dog on the axis and create any pattern that I want. So that's one thing to remember for this. So it really requires real numbers, quantitative data, but it can do with ordinal. Bar graphs, a few things I already mentioned. The fact that they work so well is because they start at the same level and they show absolute values, and you can compare those absolute values. So really the relative, they call it here point values, but it's more like absolute. Allows me to compare them. Also on the bar chart, if the goal of my visualization is to compare this with that one, it's probably the worst visualization possible because they're too far away. If they were next to each other, I can see really small differences. If they're further away, I won't be able to tell on the difference that much. But this one seems to be maybe ordered by the blue, so that's a good point to make. So if I want to do percentages, and I've seen that actually Excel would offer it to you, where the axis starts at 0% and goes to 100%. That's a little bit of a stretch for a bar chart. Yes, I see everything. So I see that, for example, if these were percentages, do they really add up to 100? Especially if they add up to 100, then that's completely not appropriate to put in a bar chart. If the percentage is from some other value that is unrelated, so percentage of employed people based on each education group, that's fine. They don't add up to 100. Because you have people with a bachelor's degree, how many are employed? People with masters, how many are employed? So the percentage is relative to each group. So in a way, it's almost like looking at an absolute value. But if the percentages add up to 100, so if I want to see the proportion of how many people with bachelor's, master's, and PhD degrees are employed, so the total is 100 because it's everyone. And then if I break it down, then we're moving into this. We need a pie chart at that point. So pie chart emphasizes, like it says, difference in proportion, but it also adds up to a whole. Not necessarily 100, but one whole thing. You have sections of a whole that you put in there. So you have all the counties in Arkansas. Well, that's fine, because Arkansas is the whole, and you kind of break down the pie that way. So that's when you would move to a pie chart. at that point. Okay, so so if everything adds up to a whole, one of these may not be good, the bar chart, because a pie chart suggests 100% one whole thing that's being broken down into subsections. If you're trying to show how many things there are, then you don't use a pie chart. So think about this way. If I look at, you know, how many types of trees. So let's say how many types of oak are in Little Rock versus how many types of oak are in Asia, the entire continent. I cannot do that with a pie chart. I see the proportion. They may look exactly the same if we break it down by some miracle. But it doesn't mean that the number of oak trees is the same. It's just the proportions are the same. So red oak, they have 10% red oak, and that may be only 3 trees in Little Rock. And then in Asia, they have, you know, 300,000 trees. It's still 3% red oak compared to the entire number of oak there. So in other words, pie chart's not good for showing absolute values. So if you want to look at how big, how many are there, you won't be able to see it in a bar chart. You get to move to in a pie chart. You need to move to a bar chart. The final one that I haven't covered, it's going to be a scatter plot. So normally you have two variables, both of them kind of change more, and you want to look at the relationship between them. So eye color and height would be something. You want to see if there's a correlation between the two. That's where a scatter plot would be. So one of the axes may be eye color, and the other may be height, or maybe a better one, rather than eye color, you're going to have weight and height, and see if there's a correlation between them. So each dot is one data point in the visualization in here. So how do we see a correlation? Like if I have height and weight in that case, the correlation would be the taller you are, the heavier you are. Most people, I mean, there's some. So what I would look for in the visualization would be, so I am taller, I expect to be heavier here. I'm shorter, I expect to be lighter. So if you look at where the points would be, they tend to form a diagonal. So if the majority of the points form a diagonal, then that means there's correlation. If that is really, if it's a perfect correlation, it's going to be one line. If it's kind of one correlation, it's going to be one single line. So in other words, the thinner this blob here, I'm going to change color. So a thin red blob tells you the correlation is pretty strong. The fatter it gets, if it gets all the way up here, it might not be correlation at all. Okay, so that's one type of correlation. Yes, the other way is inverse correlation. So notice when this one increases, this one goes down. So that shows kind of inverse correlation. There's other things you can see, but the main thing for a scatter plot will show correlation. There are other things. You can see clusters. If I'm going to clear up, if I see a lot of points, in this area, and then it's missing, and then I see another point in this area, that kind of tells me there are some clusters based on, there's nothing in between here. Kind of tells me those values don't exist. So it still gives me other information than just correlation. So it's better than an R. You can do a statistical analysis and get an R square. That'll tell you how correlated things are. Visually, again, the larger the R square, the thinner the absolute value of the R square. The fatter it is, the less correlation you're going to get. But other things you can get visually are clusters, ranges, and to see what's possible out there. So these are good. But like I said, main purpose of scatter plot, correlation. Other things are on top, the icing on the cake. So that's kind of how these very simple visualization need to be used. Lines, you'd rather have some sort of number on the axis because the line suggests that. This one shows comparison among numbers. You can see the size, how many trees. I would be able to see that in here. This one assumes there is a whole, and I can only see proportion, but not actual magnitude, how big the numbers are. And over here, it's just besting for correlation and ranges and so forth. Choosing the axis, so most of the time your independent variable is going to go on the x-axis. So sales by season, the season is going to be on the x, and the sales are going to go on the y. Experiments like, again, statistical experiment, if I'm trying to see if the temperature in the room determines how fat people are in the room, and the temperature is independent, I don't control it, but I measure the weight of people. So if the room is hotter, people get fatter. I know it's not possible, but I'm just kind of making it up there on purpose. So again, temperature will be here because it's something I don't control, it's already there, and things that I measure will go on the y-axis. And I was reading at one point many years ago, and I can't remember what, and I know some people from business take this class. I know there's one business field where they do the exact opposite of what I told you. It's tradition in that field. It's not going to change. So if you're in that field, you're going to have to kind of adapt. But I can't remember which one it is. More than one independent variable, the x-axis gets the most important one. Everything else use other properties such as color for a second one, so color by color. So these are kind of very basic things I would like you to know.